Now we are going to start a new chapter, areas, how to calculate areas by integration method. See, we are going to consider a curve of equation y is equal to f of x. We are going to find out the area enclosed by this curve y is equal to f of x in between the curve and the x-axis. In between the curve and the x-axis. Now what we are going to do, see, we are going to consider a small elementary strip of width dx and length y. Length y. Now it is a rectangular strip. It is a rectangular strip. Therefore, the area of this rectangular strip is y into delta x. Y into delta x. And this region in between these two curves, between the higher limits b and the lower limit a, in between this, the curve is made up of such a small rectangular strips of area y into dx. So, the total area enclosed by the curve y is equal to f of x and x-axis is given by the integration a to b y into delta x, which is equal to integral a to b f of x dx. That is, by integration method we are going to calculate the area. This is how we are going to calculate it. This is with respect to x, between x-axis and the curve. Similarly, between y-axis and the curve can be calculated as it is like this. See, we are going to consider a elementary strip of a rectangular elementary strip parallel to x-axis. Here, the elementary strip is parallel to y-axis. Here, the elementary strip is parallel to x-axis. Thereby, the area of this elementary strip is x into delta y, where delta y is the width of the strip and x is the length or height of the elementary strip. Therefore, rectangle area of the rectangle is x, length into breadth, that is x into delta y. And it is in between the limits from 0 to b and 0 to, that is a to b and from a and to b. The limits are a to b, x into delta y, which is equal to integral a to b g of y into delta y, where x is equal to g of y, the equation of the curve. It is given. Therefore, the area of any curve with respect to y-axis or with respect to x-axis is calculated in this fashion. And moreover, this formula we are going to use it for the problems, coming problems. We are going to use this formula. Based on this formula only, we are going to start the area of circles, area of ellipse, area of standard curves. We are going to do it. Okay, this is the one which we are going to do. So here, there are certain standard figures, circles, ellipse, parabola, all those things. We are going to find first the area of the circle x square plus y square is equal to a square by integration method. Now here you can see the figure here. The area, the radius of the circle is a, the coordinate is a0 at the end. And the strip we are going to consider is parallel to y-axis. Parallel to y-axis. Therefore, the area of the strip is y into dx. Therefore, I am going to calculate first the area of the first quadrant. There are 4 such equal quadrants are there in circle. Therefore, total area of the circle is equal to 4 times area of the one quadrant of the circle. Now, area of one quadrant of circle, see 4 into 0 to a of y into dx. Y into dx. Now, we know that the equation of the circle is x square plus y square is equal to a square. Now, therefore, y square is equal to a square minus x square. Y is equal to root of a square minus x square. Therefore, that y is equal to root of a square minus x square into dx, I am substituting here. And we know in the integration there is one formula, integral root of a square minus x square dx is equal to x by 2 root of a square minus x square plus a square by 2 sin inverse x by a. Therefore, this is equal to 4 into x by 2. That is what I have substituted here. Root of a square minus x square plus a square by 2 sine inverse x by a. Now here, I am going to apply first this limit, higher limit. Then we are going to apply lower limit. Now lower limit is everything is 0 here. You need not worry about that. Now only higher limit I am applying. A by 2 root of a square minus x square. This is 0 plus a square by 2 into sine inverse x. I am substituting a by a, that is 1. Therefore, a 4 into, this is 0, a square by 2 into sine inverse 1. But sine inverse 1 is pi by 2 because sine 90 is 1. Therefore, 4 into a square by 2 into pi by 2. This 2 into 2, 4 and 4 get cancelled, pi a square units. Therefore, area of the circle is equal to pi a square units. This is the answer for the area. Now here, second problem. Find the area of the ellipse x square by a square plus y square by b square is equal to 1, where a and b are the lengths of major and minor axes. Lengths of major and minor axis. See here, a is greater than always b. That actually it should be written a is greater than b here. Now area of the ellipse is equal to 4 times area of the one quadrant. One quadrant of the ellipse. See, each quadrant, they are equal in area. Each quadrant will have equal area. So for that what we are going to do, consider a rectangular strip of width dy and length x parallel to x-axis. I am considering this as parallel to x-axis. Therefore, area of rectangular strip is equal to x into dy, length into breadth, length into width. So, the quadrant is made up of number of such rectangular strips. Therefore, area of first quadrant is equal to integral 0 to b. This limit you have to find out, 0 to b, x into dy. Now, we know that x square by a square is equal to 1 minus y square by b square, that is b square minus y square by b square, or x square is equal to a square by b square into b square minus y square, or x is equal to square root of this, a by b root of b square minus y square. Now what we are going to do, now area of the ellipse is 4 times the first quadrant. 4 times one quadrant of ellipse, area of the ellipse. That is 4 into integral 0 to b, a by b, root of b square minus y square into dy. Now as it is, we know the formula for this, 4a by b, y by 2 root of b square minus y square, plus b square by 2 sine inverse y by b, with the limits b to 0. Now here, if you apply the first higher limit, this becomes 0. And this is b square by 2, sine inverse b by b is 1. Sine inverse b by b is 1. And if you apply the lower limit, the entire thing is 0. Therefore, 4a by b into b square by 2, sine inverse 1 is pi by 2. So, pi by 4 b square. This 4 and this 4 get cancelled. B and b, one b get cancelled. Pi a b is the area of the ellipse, which is given by this formula, pi a b square units. Now let's see the problem. Find the area of the region bounded by the curve y is equal to x square and the line y is equal to 4. You can see here, the parabola y is equal to x square is written like this. And the line is y is equal to 4. Now we have to find out the limits. First, y is equal to x square, y is equal to 4, therefore x square is equal to 4. I am equating both. X is equal to plus or minus 2. That means to say, the limits extend from minus 2 to plus 2. Now, the area of the region between the curve x squared is equal to y and y is equal to 4 is A is equal to, see there are two symmetrical regions here. You can see. It extends from 0 to 2 and 0 to minus 2. That is why we have taken A is equal to 2y, 0 to 2 of x into dy. that is 2 into integral 0 to 2 root y, because x square is equal to y, so root y into dy, that is 2 into y to the power of 3 by 2 divided by 3 by 2, which is nothing but 4 by 3. 2 to the power of 3 by 2 is nothing but 2 root 2. So 4 by 3, 2 root 2, that is 4 2s are 8, 8 root 2 divided by 3 square unit. This is the answer for that. Now second problem. Find the area of the region in the first quadrant enclosed by x-axis, line y is equal to x, and the circle x square plus y square is equal to 32. This is the first quadrant of the circle. X square plus y square is equal to 32. X-axis and the line y is equal to x. We have to find out the area in between this. See here, the area of the region O, A, B, O. That is what we wanted, that area. That area is equal to area OAN or ONA plus area of the region ANB. ANB. We have found out it. So now, before calculating the area, we have to find out the limits. First, we have to find out the limits of the coordinates n, or the limits of the coordinates of n, and limits and coordinates of b. We have to find out. Now, the coordinates of n we have to find out. Y is equal to x is given. Where the line exactly comes, we have to check. Y is equal to x means y square is equal to x square plus x square is equal to 32, 2x square is equal to 32, x square is equal to 16, x is equal to plus or minus 4. That means that the coordinates of n are 4, 0. Next, the coordinates of b we have to calculate. By keeping y is equal to 0, because we have to find out the coordinates of x. Therefore, by keeping y is equal to 0, x square is equal to 32, x is equal to square root of 32, that is 4 root 2. Therefore, the coordinates of b is 4 root 2, 0. Now, the area is equal to integral 0 to 4 y into dx, that is x into dx, because y is equal to x. So, x into dx, that is coordinates, the limits is 4, 0. That means from 0 to 4 it comes. Therefore, 0 to 4 we have written here. Next, plus integral. Next, the curve 32 minus x square, that is y into dx. 32 minus, we have to write here, don't forget, here we have to write this root. Actually, this should be written like this. So, root 32 minus x square into dx, that is x square by 2 with the limits 0 to 4 plus x by 2 root of 32 minus x square plus 32 by 2 sine inverse x over 4 root 2. Therefore, what happens here? We are going to apply limits for this. When we apply the limits for this, 4 square is 16 by 2. We can see here, I am applying here. See, x square by 2. I am applying higher limit. 4 square is 16, 16 by 2 is 8 plus. Next, I am applying first this higher limit for this. When I apply that, 32 minus 32 will be 0. This part is 0. Plus 32 by 2 is 16. Sine inverse 4 root 2 by 4 root 2 is 1. So sine inverse 1 minus lower limit. Lower limit is 4. So 4 by 2. This becomes how much? 4 by 2 is 2. 2 into 4 is 8 here. Plus this becomes plus 2, 13, 16 sine inverse 1 over root 2. 16 sine inverse 1 over root 2. Therefore, what happens here? 8 plus 8 pi. This is sine inverse 1 is pi by 2. 16 into pi by 2 is 8 pi minus 2 8s are minus 8, minus into plus minus, are you following here? Minus into plus minus 16 into sine inverse 1 over root 2 is 1 by root 2, that is pi by 4. So sine inverse 1 over root 2 is pi by 4. 4 4s are 16. So this 8 and this 8 get cancelled. 8 pi minus 4 pi will give you 4 pi square units. This is the actual answer. Now third problem, find the area of the region bounded by parabolas x square is equal to y and y square is equal to x. See here, when there is two curves are involved, to find out the areas between the two curves is given by the formula A is equal to integral A to B f of x minus g of x into dx. So this is the general formula they are given for finding out the areas in between the two curves, bounded in between two curves. So for that, here in this particular problem we have to find out the limits of integration. See, x to the power of 4 minus x is equal to 0, x into x cube minus 1 is equal to 0, therefore x is equal to 0, x is equal to 1. Now applying this formula, integral 0 to 1, f of x here, y is equal to root x, I have applied root x into dx minus y is equal to x square into dx. Now here we are individually applying x to the power of 3 by 2 divided by 3 by 2 is nothing but 2 by 3 x to the power of 3 by 2 with the limits 0 to 1 minus x cube by 3 with limits 0 to 1. This becomes 2 by 3 minus this becomes 1 by 3. 2 by 3 minus 1 by 3 is 1 by 3. So the area of this curve in between the two parabolas is 1 by 3 square units. This is the answer. Now fourth problem, find the area lying above x-axis and included between the circle x square plus y square is equal to 8x and inside the parabola y square is equal to 4x. So this is the area that is being included between x square, circle x square plus y square is equal to 8x and inside the parabola y square is equal to 4x. So this is the area, actually y, a, o, a, c, b, o. This area is the area that is being included. That is the region for which we have to find out the area. Now here we are getting this, first we will see the circle here, x square plus y square is equal to 8x. I am transferring this 8x to this side. X square minus 8x plus y square is equal to 0. You can see I am making it completing the square method. X square minus 8x plus 16 minus 16 plus y square is equal to 0. Now this is x minus 4 whole square plus y square minus 16, when it goes to that side it becomes 16. Therefore the center of the circle is 4, 0 and radius is 4 centimeter. Now coordinates of A, these coordinates of A, here y square is equal to 4x. Therefore y square is equal to 4 into 4 because the radius, the coordinates of B is 4, 0 as we know. So 4, 0, 4 into 4 is 16. Therefore y square is equal to plus or minus 4, or A is equal to the square. What is the coordinates of A? It is 4 and 4. Now similarly here, however, we have to find out the area OACBO. Now it is made up of two parts. One first, the quadrant of parabola and the first quadrant of circle. So therefore area of OABO plus area of the quadrant BACB, ABCBA. So that is given here. Now here the coordinates integral twice root of y into dx. Y into dx is root of 4x, that is square root of 4x is 2 root x dx with with the limits 0 to 4. From here to here, it is 0 to 4. We have taken. Next, plus integral 4 to 8. From here to here, this first quadrant. So that is 16 minus, here you can see here, y square is equal to 16 minus x minus 4 whole square. Therefore, y is equal to 16 root of 16 minus x minus 4 whole square dx. Now we are simplifying this integration. 2 into x to the power of 3 by 2 divided by 2 by 3, that is 3 by 2, 2 by 3. It becomes 2 by 3, 2 into 3 by 2 becomes 2 by 3, 2 into 2, 4, 4 by 3, x to the power of 3 by 2 with the limits 0 to 4 plus x minus 4 by 2, we are applying the formula root of a square minus x square into dx is equal to a by x by 2 root of x square a square minus x square plus a square by 2 sin inverse x by a, that we are applying here. Now this is the form we get here, and we are applying the limit here. You can see when we apply the limits here, what happens we will see now. Area of OACBO is equal to, see, 4 by 3, 4 to the power of 3 by 2, that becomes 64. 64 is 8. 8 fours are 32 by 3 plus, you can see here, plus x minus 4, 4 to 8, we are applying the limits. This first one becomes 0, first one becomes 0, and this is 16 by 2 sin inverse 8 minus 4 by 4, which is nothing but 8 sin inverse 1, remaining all 0. Therefore 32 by 3 plus 8 into sin inverse 1 is pi by 2, that is 4 pi plus 32 by 3. Therefore area of OACBO is equal to 4 pi plus 32 by 3 square units is the answer. Now here, fifth problem. Find the area of the region enclosed between two circles, x square plus y square is equal to 4 and x minus 2 whole square plus y square is equal to 4. See, now the circles are, we know x square plus y square is equal to 4, x minus 2 whole square plus y square is equal to 4. Now you can see the figure here. See, this is with 0, 0 center and radius 2 centimeter. And here it is, center is 2, 0, this circle center is 2, 0, and they intersect at A and C, they intersect at A and C, and we are required to find the area in between these two circles, intersection of these two circles. Now you can see they are symmetrical above and below. Therefore, we have to find out the coordinates of B as well as D. Now it is, coordinates of B is 1, 0 and coordinates of D is 2, 0. Now as such, if you want to find out the coordinates, you can find out coordinates of A. It is root 3 it becomes, because 1 plus y square is equal to 4. Therefore y square is equal to 4 minus 1 is 3. So y is equal to root 3 plus or minus root 3. Here it is 1 plus or plus root 3. Here it is 1 minus 1 minus root 3 here. Therefore we need not worry. Now we have to find out the area of the region OADCO, which is equal to twice the area OADO. Now this is equal to twice integral. Now this circle area intersection is here. Therefore the limit is 1 to 0. The limit is 1 to 0. That means 0 to 1 it goes. Root of 4 minus, here I am doing y into dx, therefore it is 4 minus x minus 2 whole square into dx. 4 minus x minus 2 whole square into dx. Plus, now another region is here, ADB. ADB. the limit is 1 to 2. The limit is 1 to 2. And it is integral. What about this circle? It is x square plus y square is equal to 4. Therefore, y square is equal to 4 minus x square. Y is equal to square root of 4 minus x square into dx. And the limit is 1 to 2. Now, after applying this formula, you can see here, and applying the lower and higher limits, we get these values as 2 into ultimate minus root 3 plus 2 pi by 3, or 2 pi minus 3 root 3 divided by 3. This goes down, so 2 pi minus 3 root 3 by 6 square units. This is the area of the region, entire region OADCO. This is the area we have got. So this is the answer for this problem. Okay, in continuation of the problems on areas, we are going to see this problem. Find the area enclosed between the parabola y square is equal to 2x minus 2 and the line y is equal to x minus 5. See, problems of this type needs the points of intersection first. We have to find out the points of intersection where y is equal to x minus 5. So this value of y, I am substituting in y square is equal to 2x minus 2. This we have substituted here. X minus 5 whole square is equal to 2x minus 2, which gives you x square minus 12x plus 27 is equal to 0. That means after factorization we get x is equal to 9 and x is equal to 3. Now, when x is equal to 9, what is the value of y on the line we have to find out? That is y is equal to x minus 5. You can see when I substitute x is equal to 9 here in y is equal to, it becomes 9 minus 5 which is equal to 4. And when x is equal to 3, what is the value of y we have to find out? So that also we have found out, it is minus 2. Therefore, the points are 9, 4 and 3 minus 2. They are the points. Now, we will plot the graph here. We will find out where exactly it comes on the parabola. See here, when we plot these values on the parabola, it directly cuts at 3 minus 2 here and 9, 4 here. And you can see the points of intersection, they lie on the one side of y-axis, that is on the same side of y-axis. They are not on the different sides. So it is not on either side of the y-axis, it is on the same side of the y-axis. Therefore, what we do, we take the limits as 4 and minus 2. The lower limit as minus 2 and upper limit as 4. That is how we have taken here. Since the points of intersection are on the same side of y-axis, I have written here a is equal to integral minus 2 to 4 f of y minus g of y dy. F of y minus g of y dy. So this is equal to 4 integral 4 to minus 2 y square plus 2. F of y is, here how you are getting this y square plus 2 into, this is x into dy actually. See here, there x square, y square is equal to 2x minus 2. Therefore, 2x is equal to y square plus 2. X is equal to y square plus 2 divided by 2. Here we have done here. Similarly, where x is equal to, when it comes to this, it becomes y plus 5. Therefore, when we integrate this, we get y cube by 3 plus 2y. This half I have taken out. Minus, this is, when I integrate y with respect to dy, it is y square by 2. When I differentiate 5 with respect to dy, it becomes 5y. So after applying this higher and lower limits, here you can see here, we have applied the limits, we get half of this value minus this. See, half of 108 by 3 minus, this is 36. Now this is, it is nothing but 18 minus 36 is minus 18 you get, or area always should be expressed in positive sign only. Therefore, we neglect this negative sign and area we take it as 18 square units. That is how we are finding the area of this. Now, same problem. Find the area of the region bounded by x square is equal to y, the line y is equal to x plus 2 and x axis. See here also same points of intersection we have to find out. X square is equal to y is equal to x square. I have substituted that x square is equal to x plus 2 and x square minus x minus 2 equal to 0. X minus 2, x plus 1 is equal to 0, x is equal to 2 and x is equal to minus 1. So when x is equal to 2, what is the value of y? Substitute this here. We get 4. When x is equal to minus 1, y is equal to 1. So the points of intersection are 2, 4 and minus 1, 1. Since you can see here, after plotting this, we see the points of intersection are on the same side of x-axis. You can see they are on the same side of x-axis. That is why a is equal to integral a to b f of x minus d of x dx, where a is equal to minus 1, b is equal to 2. So as such we have done here integral minus 1 to 2 f of x. F of x is x square into dx minus integral minus 1 to 2 f of x is x plus 2 into dx. We have integrated this, it is x cube by 3 with the limits minus 1 to 2 minus x square by 2 plus 2x with the limits minus 1 to 2. Therefore, when you substitute this, 8 by 3 plus 1 by 3 minus, now I have substituted here 4 by 2 plus 4 minus of minus 2 of minus 2, which is equal to, this is 3 because 8 plus 1 is 9, 9 by 3 is 3 minus, now this is 6, 4 plus 2 is 6 plus 3 by 2 minus of minus is plus 3 by 2, 3 minus 15 by 2 it is. So that is, if I take LCM 2, we get 6 minus 15 by 2 which is equal to minus 9 by 2. Therefore, the area is equal to 9 by 2 square units. This is the answer. Now here, next problem. Find the area of the region bounded by the triangle whose vertices are 1, 0, 2, 2, 3, 1. These are the vertices of the triangle whose area is to be found out by using integration method. See, as it is, we have plotted this graph. You can see here 1, 0 is here, 2, 2 and 3, 1. It is as triangle ABC. You have to find out the area of the triangle ABC by using the integration method. Now in this method what we are doing, we first find out the slope of the line AB, that is y2 minus y1 divided by x2 minus x1, y2 2 minus 0 divided by x2 minus x1, 2 minus 1 is equal to 2 divided by 1 is 2, slope of the line. Now equation of the line AB is equal to y minus y1 is equal to slope, that is 2 into x minus x1. X minus x1 is 1, so that we have written here. Therefore y is equal to 2 into x minus 1 is the equation of the line. Similarly, for BC we have to find out the slope. For the slope we have already calculated, it is minus 1. It is minus 1. So equation of the BC is y minus 2 is equal to minus x plus 2 or 4 minus x. Y is equal to 4 minus x. This is the equation of BC. Similarly, equation of CA you have to find out slope, that is equal to half. How it is half? y2 minus y1 divided by x2 minus x1. So that becomes half. Therefore, how much it is? Y minus 0, that is y1 is 0 here. X minus x1 x1 half of x minus 1. Therefore, y is equal to x minus 1 by 2 is the equation of CA. Now, area of the triangle ABC is equal to area of the triangle ABD. Area of the triangle ABD plus area of the trapezium BDBCE. Area of the triangle, this BDEC. Next, minus area of the triangle ACE. The total area, if you minus area, this ACE area, you will get area of triangle ABC. For that, what we do, the area is equal to, of area of ABD is equal to integral. See the limit here, it is 1 to 2. Since all the coordinates are above x-axis, we are taking only x coordinates. So, x coordinate is 1 and 2 here. Therefore, integral 1 to 2, 2 into x minus 1 into dx I have written here. Plus, area of trapezium BDEC is, here you can see, it is all the coordinates are above x-axis. Therefore, we are considering only x-axis 3 and 2. Higher limit is 3, lower limit is 2. 4 minus x into dx minus area of triangle ACE. This is ACE. Therefore, higher limit is 3 and 1. Higher limit is 3 and 1. What is the equation y into dx? It is x minus 1 by 2 into dx. Therefore, what happens here? 2 into x minus 1 whole square by 2. We have applied the formula between the limits 1 to 2 plus minus of 4 minus x whole square divided by 2 within the limits 2 to 3 minus half I have taken out x minus 1 whole square by 2 between the limits 1 and 3 we have written. After substituting all this and calculating, we get 3 by 2 square units. So area of triangle ABC is equal to how much it is? 3 by 2 square units. That is the answer. Now we shall see, find the area enclosed by the parabola 3x square is equal to 4y and the line 2y is equal to 3x plus 12. See here, we have drawn the points of intersection here. We have found out the points of intersection. See, 3x square is equal to 2 into 2y I have split. For this 2y, I have substituted the value of 3x plus 12 here. So therefore, you get 6x plus 24. Now when we take everything to the left hand side, it becomes 3 into x square minus 2x minus 8 is equal to 0. When we factorize this, it becomes x minus 4 into x plus 2. Or x is equal to 4, x is equal to minus 2. These are the values of x we get. And when we want to this y value, you substitute this value in this equation. We have substituted here, you can see 2y is equal to 3 into 4 plus 12, that is 24. Therefore, y is equal to 24 divided by 2 will give you 12. So therefore, when x is equal to 4, what is the value of y? It is 12. And similarly, 2y is equal to 3 into minus 2. I have substituted at x is equal to minus 2. 3 into minus 2 is minus 6 plus 12. Here we have that 12 I have written here. So 12 minus 6 is 6. So when x is equal to minus 2, what is the value of y? It is 3. Therefore, what happens here when we plot the graph here? You can see the points all lie above x-axis. You can see it is all lying above x-axis. Therefore, the integral area of the figure will be equal to a to b of f of x minus g of x into dx. So, if it is above, if it is on the same side of the y-axis, it is f of y minus g of y into dy. But since it is on the same side of x-axis, we have f of x minus g of x into dx. Now, what is the value a to b? A is minus 2, that is the lower limit. B is 4, that is the higher limit. Now f of x is this. So y is equal to 3x square by 2. I have written here. That is 3 by 4x square into dx minus integral. Here, what is y? 3x plus 12 divided by 2. So y. So therefore, when we integrate this, we get 3 by 4, x cubed by 3 between the limits 4 minus 2 minus, here you can see 3 by 2 into x square by 2 is this value plus 12 into x, integration of dx is x, 12x by 2. When we substitute all these values, both higher and lower values, we get 18 minus of 9 plus 36. 9 plus 36 is 45. 18 minus 45 will give you minus 27. Therefore, area is 27 square units. So that is this problem. This completes the entire area of chapter. Now we will go for the next chapter.